Okay, so again, thank you for having me here today. My name is Dr. Ashley Malin. I'm an assistant professor in the Department of Epidemiology at the University of Florida and a licensed clinical psychologist. Today I'll be talking about neurodevelopment in relation to fluoride exposure. So it has been well established now for decades that high fluoride levels can cause developmental neurotoxicity. But only in the last 10 years have studies started to examine potential impacts of chronic low-level exposures on the developing brain. And in 2012, a meta-analysis was published by Philippe Grandjean and colleagues at HSPH, Harvard School of Public Health, that looked at studies on neurodevelopmental impacts of high fluoride levels, mostly conducted in other countries. And the review concluded that the results support the possibility of an adverse effect of high fluoride exposure on children's neurodevelopment. And then in 2017, there was a landmark study published in a population based in Mexico City. This was conducted in the element cohort, and the study found that higher levels of prenatal fluoride exposure were associated with reduced IQ in the children at age 6 to 12. So they found that each 0.5 milligram per liter increase in maternal urinary fluoride in pregnancy was associated with a 2.5 point IQ reduction in the children at ages 6 to 12, as I said. Next slide, please. There was a subsequent study published in a nationally representative Canadian prospective pregnancy and birth cohort, the MIRIC cohort, published in JAMA Pediatrics in 2019. This study found that each 1 milligram per liter increase in maternal urinary fluoride across pregnancy was associated with a 4.5 point IQ reduction in the boys at ages 3 to 4. Next slide, please. And so questions have been raised as to whether these fluoride exposure levels in the Canadian and Mexican cohorts could be generalizable to those commonly encountered in the United States, whether these were typical US fluoride exposures. I led a study that was published last year that found that this was indeed the case. Urinary fluoride levels among pregnant women living in Los Angeles County were quite similar to those observed in studies conducted in Canada and Mexico that found associations of prenatal fluoride exposure with reduced IQ in children. And so there have been subsequent other studies examining prenatal fluoride exposure in relation to neurocognitive outcomes in children ranging in age from 2 to 12 years old. This one highlighted here found that in utero exposure to fluoride was associated with poor cognitive development in toddlers based in Mexico. Another study was published in Mexico City that found that higher prenatal fluoride exposure was associated with more symptoms of ADHD among children, particularly in the realm of inattention. And there was another study published in Mexico that found that higher dietary intake of fluoride exposure during pregnancy was associated with worse child cognitive outcomes in toddlerhood, particularly for boys. There was a recent study published in Calgary that found that higher exposure to fluoridated drinking water at the current recommended level was associated with poor executive function in the realm of cognitive flexibility and inhibitory control and cognitive flexibility. So those being measures of executive function. And lastly, there was a study on prenatal fluoride exposure and IQ in that same cohort, the element cohort based in Mexico City, that examined domain-specific effects of prenatal fluoride exposure and found that the decrements in IQ may particularly be in the realm of perceptual reasoning, so visual spatial function and things like that. Next slide, please. Recently, so in August, the National Toxicology Program published a comprehensive systematic review on all the literature on fluoride exposure and neurocognitive outcomes. And this is the most rigorously conducted comprehensive systematic review of its kind, particularly from a program affiliated with several government agencies. And the NTP report found, just keep hitting the clicker, thank you. You gotta, thank you. So it focused on human studies, but also included animal studies and mechanistic studies. And it included 72 studies, and most of the studies found associations of higher fluoride exposure with reduced IQ, so 64 out of the 72. They also identified 19 studies that were determined to be at low risk of bias in terms of their methodology, and of those 18 18 found associations of higher fluoride exposure with lower child IQ. So the NTP report concluded that there is moderate confidence in the body of evidence that estimated fluoride exposure is inversely associated with child IQ. And they said that this moderate confidence conclusion pertains at a minimum to those living in areas where fluoride in drinking water is known to be at or above 1.5 milligrams per liter. However, they said that associations between drinking water fluoride levels below 1.5 milligrams per liter and children's IQ remain unclear. And it's also important to mention this NTP report included studies up until 2023. So they felt that based on the evidence at that time, they could not make a determination about whether drinking water fluoride levels below 1.5 milligrams per liter could contribute to declines in child IQ, so they couldn't rule that in, but also could not rule that out. However, they noted that it's plausible that pregnant women and children living in optimally fluoridated communities could have a total fluoride intake that exceeds those of pregnant women living in regions with water fluoridated at 1.5 milligrams per liter or higher, because as it's been discussed today, there are multiple sources of fluoride exposure. Drinking water is not the only source of exposure. And so the NTP report highlighted a need for more US-based research on fluoride and neurodevelopment. I led a study that was published in JAMA Network Open last May. It was not included in the NTP report, but it found that higher prenatal fluoride exposure was associated with more neurobehavioral problems in children at age 3. So things like anxiety, emotion dysregulation, symptoms of autism, or medical complaints that don't have a known medical origin. These are the kinds of neurobehavioral problems observed. And now some questions have been raised about, what's the mechanism? Like, how could fluoride be negatively impacting the brain? We know from animal studies and also some human studies that fluoride can readily cross the placenta. It can enter the developing brain and accumulate in brain regions implicated in learning, memory, mood, attention, executive function. It can interfere with cholinergic activity and actually cause dysfunction at the same subunit receptor gene that is also implicated in ADHD. It has been shown to increase oxidative stress, and it can also alter glutamate metabolism, and that is something that has also been implicated in the etiology of anxiety disorder. In September, there was a ruling in a federal trial against the EPA. So this was widely publicized and really a historic case in terms of this fluoride issue. Next slide, please. And the ruling determined that the court finds that fluoridation of water at 0.7 milligrams per liter, which is the level presently considered optimal in the United States, poses an unreasonable risk of reduced IQ in children. The ruling stated the scientific literature in the record provides a high level of certainty that a hazard is present, that fluoride is associated with reduced IQ. So what the ruling concluded is that there is not enough of a margin of safety between the hazard level, which according to the NTP report exists at 1.5 milligrams per liter or higher, and the exposure level of fluoride in drinking water for dental caries prevention, which is 0.7 milligrams per liter. And the EPA has a default standard for there to be a factor of 10 between the hazard level and the exposure level. And so, as I mentioned, the NTP report concluded with moderate confidence the hazard to child IQ exists at 1.5 milligrams per liter. And so if we apply the EPA's default standard to that, then the fluoride concentration in drinking water would need to be 0.15 milligrams per liter or lower to provide enough of a margin of safety to protect child IQ. And so I think the question for policymakers now to address is whether you're comfortable continuing the practice, knowing that you cannot reassure the public at this time that fluoride isn't causing brain damage to children. Thank you.
Thank you.
Happy to take any questions, or you can also email me follow-up questions as well.
Thank you. 9 minutes, 55 seconds. Awesome. Questions from the commission? Mr. Force.
Did you, thank you for that quick presentation, it's very thorough. Did you give us a number, or is there a number on what the average concentration of fluoride exposure is in non-drinking water? In other words, we've heard a lot about toothpastes and other sources of fluoride that get into the human system. Is there a number on that, or is it a range, or is it not determined at the moment? I hope you understood.
So my understanding is that fluoride in dental products can be quite high, ranging from 500 parts per million or higher. Perhaps Dr. Cole, who's a dentist, might know better than me about that. But my understanding is they're astronomically high and can be catastrophic if ingested. I believe there are warnings on at least some toothpaste brands that say if you swallow more than like a pea-sized amount, contact poison control. So.
Thank you. Mr. Jean? Good. Mr. Force, anything else? No. All right, Mr. Robinson.
Yeah, quick question. So what we're hearing is that there are reasons for concern. And Doctor, I'd be interested in your practice. Do you use fluoride treatments in the context of your provision of care?
I never did, no.
And do you see any incidents of decay that would be above or below a certain level or a norm?
No, so I need to be clear. I sold my clinical practice 3 years ago. I was in Austin, Texas for almost 30 years. But in that entire time, I never did any fluoride treatments, never promoted it. I even told my patients, do you want to brush with it? You can, but I'm not selling that kind of paste in my practice. Never saw, now maybe I was in a kind of a nice area, maybe more of a, my patients were very informed and they might take better care of themselves, but no, I did not see any difference in decay rates at all.
And a question for Dr. Malin, relative to the form and substance of the fluoride, do any of the studies differentiate between the type of fluoride, whether it's calcium fluoride or other types of fluoride, and their impacts on neurological development?
Yeah, so these studies generally look at fluoride exposure from all sources, usually measured in a biomarker such as urine, most commonly, sometimes in plasma, but that will capture all types of fluoride. We know from EPA reports that community drinking water is the main source of fluoride exposure among adults in the United States.
Mayor, I do have one other question.
Yes, Mr. Force.
To both speakers, when I've examined, and others perhaps have done the same, the data on this issue, and it's mentioned in the San Francisco or the Northern California District Court ruling, studies in China and Mexico are cited, but not studies in the United States. The information presented to me today about studies in the United States was the first I've heard of any of this. And I'm wondering if you can explain that. Why did the judge not cite the studies that you cited in making the determination in that case in the Northern District of California, which was very recent?
So the judge was relying predominantly on the NTP report, as Dr. Malin said. So he was trying to condense this into something that both parties, both the plaintiffs and the defendants, could agree that were acceptable. And as Dr. Malin stated, he got down to a very small number, like 18 to 19, extremely high quality, good scientific method, low bias studies, and that's what he relied on. But yes, I showed you that there have been numerous studies that were done that were trying to prove that water fluoridation worked, but when you actually look at the data, it showed that it was very insignificant. And as Dr. Malin mentioned, she did have a study in Los Angeles, in this country, but it was just a tiny bit too late to make it to that NTP report.
Thank you.
Although the earlier study that I mentioned, looking at distributions of urinary fluoride in the pregnant women in Los Angeles, was included in the legal proceedings in the trial against the EPA. So that one was included.
Thank you. Okay. Thank you, Dr. Cole. Thank you, Dr. Malin. Appreciate you showing up here today for this important topic. And I'd like to thank the general public. It looks like we have more people in attendance today than the Water Commission normally has a privilege to see. So we are committed to continue looking at the safety of our drinking water, and the uncertainty of these recent rulings causes, I think, us to take a closer look and stay informed and keep you informed as we move forward. As I mentioned earlier, this was information only today. If we were to take a different approach moving forward, we would either have public hearings. Some cities out there in the world have done referendums, but we will keep this on the radar moving forward. So appreciate you attending today, and stay tuned. Scott, did you have anything you want to finalize here?
I too would thank people for coming. We often have an empty chamber here when we meet, so thank you.
It's an important issue. That's why you have more people here today.
Thank you. All right.
Thank you.
Up next,